Hello everyone, welcome back to Online Maths Hub. So today we are going to be solving this question right there on the screen, and that is x power y is equal to y power x. So how are we going to be solving this, and what are the solutions of this equation? And just by looking at this question, you're actually going to be seeing that there are some trivial solutions to this. Of course, if x is equal to 1 and y is equal to 1, you clearly see that it holds. And also, if x is equal to 0 and y is also equal to 0, you're actually going to be seeing that this equation holds. So, but we're going to be solving this question to actually get a solution for any value of x and y that is actually going to make this equation to hold. Okay. So just before we proceed with this video, do want to give this video a thumb up and also subscribe to our channel so that whenever we release new content, you will actually get to know about it. And of course, once you're done doing that, we're going to proceed. Of course, you can also follow us on Facebook. It is still at Online Maths Hub, and then you will also get values provided. Okay, so let's delve into this video. Well, there are a couple of ways you can actually solve this problem. Sometimes you can actually use what we call the Lambert function. You solve at some point you use what we call the Lambert W function to actually evaluate, and then you're actually going to be getting your solution. But most times I prefer to use another method, which is the substitution method, to actually solve. And so in that case, I used to set my y to be equal to say x. Okay, and then once I do this, I am actually going to go ahead to substitute in the question right there. And of course, if I do that, instead of writing my y here, I'm going to write that this is x raised to power m. X is equal to, of course, this is my y, and I'm going to write it as mx raised to power x. Okay, so at this point, I'm also going to bring out this x right here, so I can write this one as x raised to power m, or bracket x right here, and then of course I will still have this side to be mx all raised to power x. Okay, now that they are having the same power of x, what I'm going to do again is just to take the x root of both sides. So I'm just going to multiply all of this by the power of 1 over x. Okay, so if I do that, I'm going to be having that this is x raised to power m, or raised to power x, and then multiply by 1 over x is equal to mx raised to power x, and then multiply by 1 over x. And so that way you can see that this we actually cancel this, and then this one will also cancel this. And then I am going to be having that my x raised to power m is equal to mx. Okay, so at this point I will proceed to divide through by x so that I can actually bring the x's to one side. And if I do that, we'll have x raised to power m divided by x, and then mx divided by x right here. And of course, this s can cancel this, and then I can evaluate this using one of the rules of indices, which this side is actually going to give me x raised to power m minus 1. Okay, and of course it is equal to m. Okay, so this is what I have, and of course to get my x from here, what I'm going to do is just to multiply both sides by the power of 1 over m minus 1. If I do that, I will have that this is x raised to power m minus 1 multiplied by, okay, let me just put it in bracket, m minus 1 over m minus 1 is equal to m raised to power m, that is 1 minus m. Okay, so clearly this will deal with this, and eventually I'm getting that my x is actually m raised to power 1 minus 1. Okay, so it's pretty much simple. Okay, so solving for y, let me just continue from here. If you remember here, I actually set my y to be equal to mx, and I've gotten my x. So you can see that clearly that my y is actually going to give me m into m raised to power 1 divided by m minus 1. Okay, and of course clearly you can see that this is m times m raised to power 1 divided by 1 m minus 1. Okay, so using the product rule for indices, I'm going to be having that this is equal to m raised to power 1 plus 1 over m minus 1. Okay, now moving further, this is, I can actually write this as this one here as m minus 1 all divided by m minus 1, okay, plus the other fraction 1 divided by m minus 1. Okay, so at this point I'm going to be having that my y is equal to m raised to power m minus 1 plus 1 will be I will left with m all divided by m minus 1. So this is actually going to be the value for m, and it will be the value for. And so I'm just going to go ahead to pick values for m, and then I'm going to try to see whether this actually satisfies the equation. Okay, so let's just run a field check right here. Okay, now let's take our m to be equal to 2, and if I do that, don't forget our x is equal to m raised to power 1 divided by m minus 1. And so if my m is equal to, I'm going to be having that this is 2 raised to power 1 over, that is a 2 minus 1. So clearly my x is equal to 2. Okay, and then of course my y is also going to be, this is my y right there, so I'll put 2 right there, 2 divided 2, sorry, this is 2, okay, 2 raised to power, and then m is right there, this is 2 also, divided by 2 minus 1 is actually 1, so this is clearly a 2 raised to power 2. Okay, so clearly this is 4. You can see that my x is equal to 2, and then of course my y is equal to 4 when my m is equal to 2. So to show that it holds, if we plug it in the question, right, then the question we're actually solving is x raised to power y is equal to y raised to power x. Okay, so my x is equal to 2 right here, and then my y is equal to 4. Is now I'm going to check whether it's the same as 4 raised to power 2, and of course clearly this is 16 and this is also 16, so it holds. Now let me just check another one. So let me take my m to be equal to 3, and if I do that, my x right here, my x is actually going to give me 1 over 3 raised to power 1 over 2, and then my y will give me 3 raised to power 3 over 2. Okay, so I'm going to check whether this actually holds, and now plugging it in this question right here, I'm having that my x is equal to 3 raised to power 1 over 2. Okay, and then my y, I'm going to put that in bracket, my y is equal to 3 raised to power 3 over 2, and then it is equal to my y is 3 raised to power 3 over 2, and then I'm going to put this one in bracket, my x is 3 raised to power 1 over 2. So I want to check whether this is same as this. Okay, so I'm going to simplify this further right here. So I'm going to be having that this is 3 raised to power 1 over 2, and then this stuff that you see right here, I can actually split it into, this is root 3 up to 3 times. So I'm going to write this root 3 times root 3 times root 3. Okay, and of course it's equal to this one we see here, this is 3 raised to power 3 over 2, and then multiply by root 3. Okay, now this has appeared 3 times. I can write it as 3 times root 3. This is 3 raised to power 1 over 2 multiplied by 3 root 3 right there, and then it is equal to this one. I can write it as 3 raised to power 3 root 3 divided by 2, and of course clearly you can see that 2 of them is equal 3 root 3 divided by 2 is same as 3 power 3 root 3 divided by 2, and of course it, so you can actually pick any value of m, and then you will be generating the values of x and the y that actually makes that equation to hold. So thank you so much, and of course let me have your thought in the comment section, and I'm gonna see you guys in my next video. Bye.